Hey everyone, and welcome. Today, we're cracking open the Beginner's Machine Learning Toolkit. And you know what? Let's forget about all the scary math for a second. We're going to focus on how to turn these super powerful algorithms into simple, practical tools you can actually start using. Let's jump right in.
Have you ever looked at machine learning and just thought, no, that's not for me, that's way too complicated? That it's some kind of secret art form reserved for people with PhDs in advanced mathematics? Well, I'm here to tell you that that is one of the biggest myths out there.
See, the myth is that to use machine learning, you have to be able to build it from the ground up. That you need to be able to write out all the complex calculus and linear algebra behind every single algorithm. But it's like saying that to drive a car, you first have to know how to build an engine. You don't. You just need to know how to use the tools you're given.
And here is the secret, okay? Getting started with machine learning is way more like being a chef than it is being a mathematician. You've got this amazing kitchen full of pre-built tools, and you just need to follow a simple, repeatable recipe to get some really incredible results. And you want to know the best part? For pretty much every common machine learning model, especially inside the super popular scikit-learn library, the code recipe is, and I mean this, exactly the same. This is huge. It means you only have to learn one simple pattern to unlock dozens of different models. It's an incredible shortcut. So what is this magic recipe, right? Well, it boils down to just 4 simple steps. First, you import the specific tool you need. Think of this as grabbing the right wrench from your toolbox. Second, you create the model, which is like, having that wrench in your hand, ready to go. Third, you train the model on your data. This is the part where it actually learns. And finally, step 4, you use it to make a prediction. That's it. Import, create, train, predict. We are about to see this exact pattern over and over again. All right, so with that 4-step recipe in our back pocket, let's take a quick tour of the most essential tools in our new machine learning toolkit. And for each one, we'll give it a simple analogy so you'll never forget what it does. Our first tool is linear regression, but I just like to call it the ruler. Its job is really simple: predict a number. So imagine you plot a bunch of dots on a graph for a kid's age and height. This tool just finds the one single straight line that best cuts through all those dots. That's it. So now you can predict a height for any age. Simple, right? And here's our pattern in action. Just look at this code for a second. That first line, from sklearn.linearModel import linear regression, that's our import step. We're just telling Python, hey, go into the scikit-learn library, we call it sklearn for short, find the linear model folder, and bring me the linear regression tool. Then that second line, model equals linear regression, that's our create step. We're just making a fresh, ready-to-use version of that tool and calling it model. All that's left is to train it and make predictions. These 2 lines are the core of everything. Next up, we've got logistic regression, or as I call it, the separator. Now, don't let the name fool you on this one. Even though it has regression right in the name, this tool is actually for classification. That means predicting a category like yes or no, or is this email spam or not spam. It works by drawing a boundary line that cleanly separates 2 different groups of data. Okay, so let's check out the code. Notice anything familiar? How similar this is to what we just saw? We literally just swapped out the name linear regression for logistic regression in our import. That's the only change. The create step, model equals logistic regression, is identical. So just by changing one single word, we've switched from a number predicting ruler to a category predicting separator. This is the real power of the toolkit. Our third tool is the decision tree, which is basically just the flowchart. Honestly, this is one of the most intuitive models out there. It works exactly like a game of 20 questions. It just asks a whole series of simple yes or no questions to narrow down the possibilities until it gets to a final answer. Its biggest advantage is that it's super easy to explain to literally anyone. And how do we get this flowchart ready to go in our code? I bet you can already guess the pattern. We go to scikit-learn's tree module, and we import decision tree classifier. Then we create our model instance. Boom, just like that, our flowchart is ready to be trained.
So what could possibly be better than one decision tree? How about a whole forest of them? Well, that is the big idea behind our next tool, the random forest. I like to call it the Council of Elders. It builds hundreds of slightly different decision trees and then has all of them vote on the final answer. It's basically the wisdom of the crowd, but for data.
And to assemble this incredibly powerful council of elders, the code is, well, it's almost laughably simple. Following our pattern, we just import random forest classifier and then we create it. Just let that sink in for a second. With 2 lines of code, you have just brought into existence one of the most powerful and widely used machine learning models on the planet. That is amazing. So this brings up a really crucial trade-off in machine learning, the constant battle between interpretability and accuracy. A single decision tree is fantastic because you can literally print it out and show your boss exactly why a decision was made. It's easy to explain. But a random forest will almost always give you a more accurate prediction. The catch? It's a black box, meaning it's really hard to explain why it made its decision. So you have to ask yourself, is it more important to have the best possible result, or is it more important to be able to explain the logic?
All right, our next tool takes a very social approach to things. It's called K-nearest neighbors, or just the copycat. The logic is dead simple. You are who your friends are. To figure out a new unknown data point, it just looks at its K closest neighbors in the existing data, and it copies whatever they are. If you're surrounded by a bunch of blue dots, well, you're probably a blue dot too.
And at this point, you are basically an expert in this pattern. To get our copycat model ready, we import K-nearest classifier from the neighbors module. And then, you guessed it, we create our model. It's this beautiful, consistent design that makes scikit-learn such an amazing place to start. The pattern just works every time. Okay, our final tool for today is the support vector machine, or the boundary. Now, just like logistic regression, it separates two groups. But the SVM is a little different. It's not just looking for any boundary. It's looking for the boundary that creates the widest possible gap, like a street, between the two groups. Think of it like building the most robust, widest fence you possibly can between two different herds of animals. And for our very last tool, the pattern holds strong. We go to the SVM module and we import SVC, which just stands for Support Vector Classifier. Then we create it with model equals SVC, and that is it. 6 different tools, 6 powerful concepts, and all of them are unlocked by the exact same simple coding pattern. You now have the keys to start using every single one of these. So let's put it all together. Here is your machine learning cheat sheet. We have our ruler for predicting numbers, and then we have our 5 powerhouse classification tools: the separator, the flowchart, the council of elders, the copycat, and the boundary. Each one has a totally different strategy, but now you have a clear mental model for what each one is trying to do. Okay, so we've busted the myth that this is too hard. We have learned the universal recipe, and we've toured the entire toolkit. So now the question isn't, can I do this? The question becomes, what am I gonna do with this? The focus shifts from just learning to actually doing. If you remember only one thing today, please let it be this. The core process for getting any of these models ready to go is always the same 3 steps: import, create, and train. That third step, training, is what gets your model ready for the 4th and final step, making predictions. This simple pattern unlocks an entire world of powerful tech. You now have a solid grasp of 6 of the most important algorithms in all of machine learning. You have the analogies to understand the concepts, and you have the universal code pattern to actually bring them to life. The toolkit is officially in your hands. So the only question left is, what problem are you going to solve first?